can see my screen. And yes, today I'll be speaking about assessing the cumulative impacts of wind farms on birds. So a small introduction about myself and where I'm from. I'm Elizabeth Marsden. I work at the University of the Highlands and Islands in Scotland, which is actually Scotland's newest university. And we have 13 campuses across the Highlands. I'm based at the Environmental Research Institute, which itself is part of one of those campuses, the North Highland College. And we're based in Thurso, which is on the far north coast of the mainland of Scotland here on the map. And as an institute, we are approximately 40 staff and research students. And briefly, I work along others in an ornithology research group. Most of our research is about birds and renewable energy, both terrestrial, onshore and offshore, as well as renewable energy. Or as part of that work on renewable energy, we look at cumulative impacts, but also we look at other impacts of human activities on birds, including the impact of marine debris, so plastics, on seabirds. That's just a small introduction to me and the research group, so you know a little bit about who I am. But on to the presentation today. So in the presentation, I'll try to cover these topics. What are cumulative impacts? The methods used in cumulative impact assessments, the challenges that we faced in the UK and Europe, the lessons we've learned from trying to do these cumulative impact assessments, plus examples along the way. So cumulative impacts and cumulative impact assessments. Why are we interested? There's increasing numbers of wind farms, as has just been said in Japan, as well as in Europe, in the UK, in Scotland. And we can no longer think about the impacts or the effects of one wind farm on birds. We have to think about all of these different developments together, which might be combined, the cumulative impact of all of these wind farms. But there are many different opinions on how you might actually do that. As has already just been said, it's often unclear what is actually cumulative, what is meant by cumulative impacts, and there's often no standard method for assessment. And that has been the case in the UK. It's not just a situation in Japan or elsewhere in the world. But in the UK, cumulative impacts are now affecting wind development progress. And I'm about to give an example of one which is called Docking Shoal. So Docking Shoal was a wind farm development that was proposed. It had 108 turbines. On the right, there's a picture of the UK. The red circle shows the approximate area of an area called the Wash. Within that, there were a number of different turbine developments, as you can see in the lower picture, and there Docking Shoal has been highlighted, but you should be able to see there were quite a few developments, offshore developments within one area. So this was the first UK offshore wind farm to be refused planning consent. It wasn't allowed to go ahead. And it was being considered alongside two other wind farms, the Racebank and Dudgeon. And it was refused consent because it was thought that there would be adverse, negative cumulative effects on breeding birds, on breeding sandwich terns. And in the assessment, it was thought that the Docking Shoal wind farm would have a disproportionate, a greater impact than the other two. So that was the one that was refused planning consent. And this was really the first time that cumulative impacts really caused the problem for planning and development of wind farms. And although cumulative impact assessment had been required, it had been done as an add-on, I would say, in the EIAs of projects. It was there, but it wasn't necessarily done particularly well. And this was then the first time where people really thought, okay, we need to pay more attention to this. So what are cumulative impacts and cumulative impact assessment? So within the UK and Europe, there is guidance from legislation and from authorities. So here's some text from guidance, which I'll just highlight some elements of, which states that cumulative effects or cumulative impacts are the impacts that result from incremental, potentially small changes caused by past, present, and reasonably foreseeable into the future actions. And here, actions actually isn't defined, so whether you just include wind farms or wind farms and other developments is unclear, but together with your project that you're thinking about. But then also guidance from, as then, Scottish Natural Heritage, but now called Nature Scot, said we should think about the additional changes caused by a proposed development in conjunction with, here it states, similar developments. So here probably talking only about wind farms. But hopefully you can see these aren't, I would say, particularly clear or definite. Then further in Europe, again, from an EC directive, it stated on environmental impact assessments that the characteristics of development must be considered having regard to or the accumulation with other developments. Here particularly, I think the cumulative element refers to developments, your development that you're thinking about in combination with others. But then also in that directive, it talks about cumulative in a slightly different way, which I think refers more to time. So a description of the likely significant effects of the development on the environment, which should cover the cumulative effects of the development. So talking about one development, but thinking about it over time. So ultimately, I don't think these are particularly clear. So what does it really mean? I did a piece of work on this, and please, the equation is there mainly for my benefit as a prompt. This piece of work was to produce a conceptual framework, a way to think about cumulative impacts, and to try and break it down, to produce a framework for planning and assessment, a way to try and think about all the possible elements of the puzzle, of the problem that you're thinking about that could be considered cumulative. And at simplest, I think of it as a checklist, a way to try and make things clear so that everybody knows what you're thinking about. Everybody is thinking the same thing. And now I'll walk through this equation. You really do not need to think about it particularly. Just note the different elements as I go through it. And if you want more information, there is a paper in English, which is highlighted at the bottom. So what we were saying was that cumulative impact is the sum of impacts themselves. And those impacts come from developments. Here we've called them actions, but they're developments. Here we can think about wind farm developments, 1 or 2 or 3. But is it just wind farm developments that might actually affect the birds that you're thinking about? Or are there also other things that are going to affect those birds? And here, those are all included in this development. What is it that you're actually including in the assessment? And then the receptors, the individuals or the species that you're thinking about. These can also be considered cumulative. You might be thinking about one species or multiple species. You might be thinking about 10 individuals or all the individuals within a population, but you need to understand or decide from the beginning what it is that you're thinking about, because this needs to be clear. And on that, which species should you include or consider? So it may be that in an area you already know which species are present, but you might not know whether you think they're vulnerable or sensitive to the wind farms. And here are two pieces of work that I was involved in. The one on the left is trying to assess the vulnerability of marine birds to offshore wind farms. The one on the right followed on and was actually looking at assessing the vulnerability or sensitivity of marine birds and coastal birds to putting turbines on fish farms. So if you already have birds around a fish farm and then you put wind turbines and you add them there, what happens? But with both, the idea is you look at the species in the area. That a bird might be flying at the same height as the turbine blades. How agile is the bird in flight? Will it be able to move around those turbines to avoid collision? How much of the time is it actually flying? All these things added up together to give a risk score to think about which bird species might actually be top of the list that we need to think about. And that can also be taken into a sort of spatial context. And this is work that was done quite a while ago now, but lots of other people have replicated it in different places and perhaps in Hokkaido even. But the idea is you look at across an area which bird species are present, and then essentially you add them all up to say in which areas are there lots of birds which might be sensitive to wind farms. And that can be used as a planning tool to say, actually, these areas would be really bad to put wind turbines in. And these ones would be less so. There are fewer birds that might be sensitive in that area. So it's a sensitivity mapping way of thinking about planning. Okay, so back to this framework. So another thing that could be considered cumulative is space. So the spatial scale. Is it just a very small area? Is it the area of your wind farm and 3 neighboring wind farms? Or is it a region? Is it the whole of Japan that we're thinking about? And also, what is the time scale we're talking about? Again, you could consider that cumulative. So is it a short amount of time? Is it a few years? Is it the lifespan or the expected lifespan of the development of the wind turbines? Is it the breeding season of the bird? Is it the lifespan of the bird? All of these are slightly different. Or is it a 100-year period we're talking about? Those different scales need to be thought about and decided upon, I would say, so that everybody knows what this assessment needs to include. And there are no set rules on this. Often this is done in consultation, and it's an iterative process that goes backwards and forwards between all interested parties in the UK to set that envelope, those boundaries of space and time and species to be considered and which developments to be considered. Okay, so here's an example for you, which was done by the British Trust for Ornithology. I was also included in it. So was the University of Amsterdam, because it was a tracking project and we used their GPS tags, and it was funded by the Department of Energy and Climate Change in the UK. And it was GPS tracking of lesser black-backed gulls at 3 breeding sites in the UK. And the idea was to look at the vulnerability to collision with wind turbines throughout the year across the breeding and wintering ranges. So often in the UK, this wouldn't happen as a cumulative impact assessment that a project would do. This was done through collaboration and knowing that actually we should really be thinking on the scale of the bird. Where does the bird go? What does the bird experience? Rather than simply on the scale of a development or a few developments. And again, if you're interested, apologies, it's in English again. There's a paper with more details on this. So this all started off with a lot of GPS tracking data of blackback gulls, as I said, from 3 colonies. One in Orford Ness, one in Walney, and one in Stockholm, all of them in the UK. And then throughout their breeding season, these birds travel down through Europe into North Africa and back again. And along the way, here are the wind farm locations that there are in these different countries. So similar in one sense to the images that you just saw of different wind turbines in Japan. So from those locations, you can get a measure of wind turbine density in grid squares of kilometers scale. Of course, you could do that for any distance, any gridded distance, but here, this is the scale that was used. You can see. And then from this turbine density, we combined that information with the distance traveled by these birds that were tracked in a vertical collision window. And by this, I mean the amount of time they spent flying at the same height as the rotors would be turning of the wind turbines. And this information came from the GPS tracks because there was altitude available for them. So then we could combine the amount of time a bird spent flying at a risk height with whether or not there was turbines and how many turbines in that given grid square to get a vulnerability map across the whole range throughout the year. And you can see, hopefully here highlighted, that around the breeding colonies, there were areas that were higher risk. These birds were spending more time there, and also there were wind turbines in the area. But also there were areas of higher risk, these yellow, orange, red to dark red and brown areas in Europe where these birds were spending the winter. So actually it wasn't just the areas where they were breeding that should be considered as high risk, but across the range. So this looked at, in particular, what activities and developments should be included. As I said, often it's simply the developments, or one development with a few developments in a restricted area. It often does not cross international boundaries, as this study did. So it would just be within the UK area usually, which goes on to what spatial scale are you actually talking about? Is the spatial scale one which is relevant to the birds, or actually is it just relevant to planning? And if it's just relevant to planning, then it should be carefully considered whether it's giving you the information that you actually need in terms of the impact on the bird population. So moving on, I was also involved in some work on cumulative impact assessment guidelines, and I think these could be quite useful for many different countries who are, I suppose, slightly behind in the rate of development, perhaps than the UK, and a way to learn from mistakes that the UK has maybe made. And so what we were trying to do here was provide solutions to overcome the challenges of cumulative impact assessment. Because there are many, it's acknowledged that there are many. It is hard to do cumulative impact assessments. It's hard even to think about cumulative impacts. And so we came up with a number of principles. And I'll just give you one example here, rather than dwelling on all of them. So if we think about one of the scoping principles, so something to think about when you're trying to decide what even to include in a cumulative impact assessment. And what was decided or came out of multiple workshops when thinking about this topic was that the boundaries for the spatial and temporal scales of the cumulative impact assessment should be set in consultation together with regulators, with advisors, with key stakeholders, with all the people involved, and in line with the best available data. So you need to make sure that you have the data available at the scale that you're trying to do the work at. Because if you're trying to do something but the data just aren't available, then it's never going to be a good outcome. But the key here is the consultation, making sure everybody is in agreement from the beginning helps hugely. And this leads on again to another piece of work that I did about uncertainty. And it's essentially the same idea. And this was a case for offshore wind and birds in the UK. But one of the things that we were saying was that linguistic uncertainty, the uncertainty that surrounds language, really makes cumulative impact assessment harder. As I said, it's a difficult topic. Hopefully I'm doing an okay job of talking about this today, but it is hard. It's hard to make sure that the words that you use are understandable by everybody in the room. So having consistent language, having clear definitions that everybody has agreed to, and follow guidelines and using case study examples can really, really help to make sure that everybody understands what it is that everybody's aiming for. What is it that is the aim, the end goal of the cumulative impact assessment? And here there's a quote from Adrian Judd and others, which essentially was saying the same thing, that they recommended the use and definition of terms, that it was essential if attempts to develop cumulative, and here they use effect assessment, which is again just highlighting the point that some people call it cumulative impact assessment and some people call it cumulative effect assessment. But either way, the use and definition of terms is key to making sure that there's wider acceptance of the results that come out finally. Because even if you do a cumulative impact assessment, if the results that you get are uncertain and not everybody actually believes them, then that isn't a good outcome either. So having buy-in from everybody and understanding from the very beginning is really important. Okay, so again, as I said at the beginning, there are multiple ways, so many different approaches that people have taken to cumulative impact assessment. And I was involved in a piece of work for the Scottish Wind Farm Bird Steering Group to review all the different cumulative impact assessments that have been done that we could get our hands on in the context of the onshore wind farm industry in Scotland. And what we were doing, again, this was in collaboration with the British Trust for Ornithology, was to review all the methods and try and see just what people were doing, because we thought everybody was doing something different, and to try and look and understand just the state of the situation. We were able to essentially categorize those cumulative impact assessments into 4 different groups. And the first one, and I'd say the one that most of those assessments fell into, was qualitative. This was descriptions of what people thought the cumulative impact might be. It might have been classifying them approximately into some traffic light system of green, perhaps okay, orange, a little concern, red, a lot of concern. It might have been some expert opinion, but it was not quantitative. It was definitely descriptive. And that was where the majority of those assessments sat that we found. The next group, which was sort of a step up, we called those that took a summing approach, summation. They were able to put a number to quantify to some degree what they thought impacts might be. For example, they may have had the number of collisions estimated using a collision risk model from their wind farm and added it together with the neighboring wind farms. summation could also be considered. Sorry, the example that I gave of the sensitivity map, where different grid scale cells had different numbers of species, that could also be considered a summation approach. You're adding up the number of species at risk in different squares on a map. And equally, the example that I just gave about lesser blackback gulls, that was a summation approach, a probably more complex summation approach, but still, it was looking at where did birds go? How many wind farms did they experience along their annual migration down through Europe and back again? It was summing up the risk. So there are, again, different ways of using a summation approach, but there were some that used summation. Often it was as simple as adding up potential numbers of dead birds. Moving on, the next one we call demographic models, population models of some degree. So there they may have taken the outputs of collision risk models, the estimated number of birds that might collide and die with wind turbines, but then combine that with information about the bird's life history. So adding the additional mortality to what you may already know about bird survival, and then seeing how that affects the population trends. Is it enough to push a population into a decline or not? And then finally, there were some, and I would say these were generally academic papers rather than methods that were generally used actually by the industry, but there were individual based models. These then are models or methods that go even further than the demographic ones. They think about the information about birds' life history, but also try and include information about bird behavior. How do birds move through an environment? Do they avoid turbines? Which habitats do they use? And how does placing wind turbines on a landscape impact the bird behavior? Okay, so this is an image that was put together by my colleague. And it was to try and pull together all that information that we'd found about the different methods. And essentially, as you move from left to right here, there's increasing complexity. So on the left, there's the qualitative assessments that I described, the expert opinion or the descriptive classification of what is thought to be the impacts and the cumulative impacts. There's the simple summation, moving through to matrix models, which are a type of population model. Taking that a bit further, perhaps to more time series analyses, the population viability analyses, the ones that look at over time what might happen to a population if there's impacts of these multiple wind farm developments. And then on the far right, the agent-based or individual-based models that I mentioned, the ones where these are simulation models, which try and look at the birth and deaths, the movements of individuals, the behavior of individuals, and the effects that the wind farms may have on them. From the left, you may need minimal data, all the way to the right, where you will need a lot of data to be able to do these things, a lot of time, computing power. But in some circumstances, these can be very informative, especially if you have a species which you think may be very high vulnerability or a very specific case in one area. But what we were saying is that a lot of the assessments that we reviewed in that study sat on the left. They were these qualitative assessments. And what we need to do is to try and push them along the right. We don't need to necessarily go all the way to individual-based models. But I think if we really want to try and start to understand the cumulative impacts, we need to at least try and make things quantitative. So push it a little bit along this arrow. And depending on how much data you might have, or indeed how much of a problem you might think you have, will dictate how far along you might go. But still, try and move away from the qualitative into the quantitative assessments. Individual-based models was one of these groups. And now I'm going to give you a case study of hen harriers in Scotland, a piece of work that I did actually for my own PhD. So it's a little old now, but there isn't really still another example of this, particularly for onshore. So I'm giving you this one. And hopefully it will show you what can be done if you have data available. And sometimes you just won't, or there won't be the need to go this far, this in-depth into assessing cumulative impacts. But this is possible. It's one thing that you can do. Okay, so this was an individual-based model. It was spatially explicit. So this is very much a model, a computer-based model of pretend birds flying around in a space. It was parameterized with real data. So all of the decisions, all of the things about these pretend birds, for want of a better phrase, come from data. It was for hen harriers in Orkney in Scotland. And when we're thinking about cumulative and what was cumulative, the number of wind farms or wind turbines, sorry, was cumulative. The number of individuals, it was not one individual, it was multiple. And the processes were also cumulative. And I'll explain that a little more in a moment. And of course, it required data on the demographics, so the survival, the reproductive success of these birds, on the behavior of these birds. What food were they eating? How much? What habitats did they use? But also, what behaviors, display flights did they do? And at what heights are these? Thinking about whether they might collide with wind turbines. And then nest site locations. So the actual locations in the real world where these birds were relative to where wind turbines might be placed. So it was a lot of data that were required. Okay, so this was for hen harriers, as I said. And this is a schematic to show essentially the steps within the model that happened. It happened or worked on an annual cycle, so 12 months in the life of a bird, and then it repeated. So at the beginning, you have a number of juveniles who didn't breed and a number of adults that did breed. To do that, the adults selected a nest site. Then they did here what I've called skydance, which is a risky behavior for these birds because it puts them in the range of the turning rotors of the turbines. So there's a risk of colliding and mortality, of dying. But if they don't, they go through and breed. That is dependent on the habitat quality, which can be impacted by where you place turbines. And out of that comes the breeding adults and new juveniles. There's a process of overwintering, and then you go right back round to the beginning again. So those are the steps in this. And wind turbines could impact the birds through collision mortality. As I said, sky dancing, this breeding behavior, display behavior. The birds fly up to heights where the turbines are moving, and also just in daily movements, they may fly at collision risk heights. So that was one way that the turbines could impact the birds, but also habitat loss. So where you're actually placing the turbines, the footprint of that actual development. The land is no longer there. And if that's on habitat where the birds would usually nest, that's now gone. They can't access it. So for collision mortality, to model collision, it was a product or a function. It depended on the number of turbines and the flight activity of the bird. I mentioned that already. And for habitat loss, it was dependent, in this case, on the percentage of rough grass in the hen harrier's territory, because it had been shown that this linked directly to the number of chicks that they produced. But also, there was another way in which the turbines could affect the birds, because they avoided the turbines. So there was a probability of occurrence. How many birds would you see close to or far away from turbines? And we use that information also to feed it into the model. Now to the model itself, in terms of how do we decide about the turbines. So in Orkney, at the time when this was done, there was some wind turbines installed and then some planned. That just made for a total of 7. And then I made locations within the landscape of twice as many, 4 times as many, 8 times as many, and 16 times as many. So in the end, there will be 5 different scenarios, one with 7 turbines, then 14, 28, 56, and 112 within an area. And then these turbines could be placed in different ways. The worst case being very close to the nests, because we knew that the hen harriers did not like the turbines being close and they would avoid. Then they could be away from nests. They could be not in their preferred habitat, this rough grassland, or they could be away from nests and not in rough grassland, which was the least bad, I would say. Probably not the best solution for the birds, but the least bad option of these 4. Okay, so here's a result. This is simply to show you what can be done with these kinds of models. And I'll try and walk you through what's here on the page. So there's 4 panels, A, B, C, and D. And these are the different numbers of turbines. So twice as many as the original 7 turbines, 4 times, 8 times, and 16 times. A being the fewest, D being the most. The different colored lines represent the different placements of the turbines. So very close to the nests being red, within 2 kilometers, through to outside 2 kilometers and not in the preferred rough grass habitat. And then the black was considered the control. That was 7 turbines that were currently installed and proposed in Orkney at that time. So these lines, or the data, show the number of simulations that I ran that ended up below 10% of the starting population. So there's a proportion of simulations below 7 adults. And what you can see, the main point of this, is that was when there's fewer turbines, so in the panel A, then not many simulations ended up with very few birds, with 10% of the starting population. But as you move through, you get more and more birds essentially dying along the 50-year period for which I ran these models. And so in the panel D, you can see that when you place turbines within 2 kilometers of nests, by the end of a 50-year period, all of the simulations, 100% of the simulations, all ended up with very, very few birds. So it's a way of being able to test different scenarios you may have. If you have different planning suggestions where to place turbines, this is a way, should you have the data available on the birds, a way to try and make decisions as to which of your plans may be least impacting on a population. The other thing that you can do with these models is to try and pick apart the different ways in which the wind turbines, the wind farms may be impacting the birds. So because of the way I constructed the model, I was able to separate out the impacts of habitat loss and the impacts of collision mortality. And this is what I meant earlier about considering the different processes, the different ways in which wind farms may combine to be cumulative. So here, what I show is that when you only consider 7 turbines, and that is for the black and the green lines, whether you include collision, mortality, and habitat loss, that's the black, or whether you just include just include habitat loss and do not include collision, there's very little difference when you're thinking about small numbers of turbines. But once you get up to the worst case scenario that I had in my modeling, which was over 100 turbines, then there is an effect of including both habitat loss and collision mortality. Because here you can see that without collision, the blue line, there's more adults alive at the end of the simulation than when there's both habitat loss and collision mortality, which is the red line. So it's a way of trying to understand which processes are impacting the population, how to pull it all apart, to get better understanding of how to have developments, but also protect species of interest. So I think individual-based models can be really useful for specific cases. If there's been highlighted a species which is of great concern in a restricted area, perhaps, it allows you for scenario testing. If you have different planning regimes or different options of different numbers of wind turbines, wind farms in an area, you can look at that together, and it can provide a detailed understanding of the system. But it requires a lot of data and a lot of information, which is not always available. Okay, so I'm going to move on now. Until the end of my presentation, I'll give you some thoughts, both from the USA, from workshops that have been held over there, and also of a few new projects that I'm involved in that might be of interest. Okay, so from the USA, they're at a state, particularly in offshore wind energy, they're at the very beginning. There are a few developments, but before they get too many developments, the New York State Environmental Technical Working Group wanted to try and think about cumulative impacts. In particular, they wanted to try and learn from the UK. And they organized a State of the Science workshop on wildlife and offshore wind energy, not just looking at birds, but one element was birds. And all of the reports from the workshops, again, though in English, are available at that web link. And what they were doing was trying to have a prioritization of research needs exercise. They were trying to think, before cumulative impacts actually become a problem in US waters, what do we need to do? How do we need to learn from the mistakes of everybody else? How do we need to do things in a way that will be beneficial? And they came up with lots of different priorities that ended up being ranked. And I'm just going to show you a couple of them, give a couple of examples that I think are relevant. So one of the priorities that they highlighted was to develop an exposure or vulnerability risk matrix, essentially to identify the priority species, and to do that by lease area or development area, so that they understand which species it is that they should be interested in. So to try and quantify the exposure or the potential vulnerability within those development areas, to better inform the siting of wind farms and the risk assessments, but also to identify where they don't have knowledge yet, identify what data need to be collected, and do that before it gets to a point, as with Docking Shoal, cumulative impacts might start to restrict developments. Another example was developing standardized protocols for collecting and storing survey data. And so what they were saying was that in the US, there's no centralized database or accepted standards for data types from offshore wind farm monitoring, and that actually that would be beneficial. Now, this is something that is an absolute problem in the UK. So this was not thought about in the UK to begin with. This is a case both onshore and offshore. Data have been collected in different ways. They've been stored in different places. Different types of data have been stored and collected. So when you try then to do a cumulative impact assessment, it is incredibly difficult to combine those different types of data. There also may be limited data on any forms of error. So it makes it incredibly challenging. And from this workshop, what colleagues in the US were trying to do was to think, okay, before we get to that point, can we do it now? When we're collecting the data now, can we think about this so that we don't end up in a situation like in the UK, where you're trying to do cumulative impact assessments and everything is different, all the data are different, and it is really, really challenging to pull it all together. In some cases, you just can't because it's so different. Okay, so finally, I thought I'd give you just some information about current projects that I'm involved in that are relevant. And one is this, a cumulative effects framework project for key ecological receptors, which is mainly marine mammals and seabirds, because it's for offshore wind farms. And the project is funded by the Marine, Maritime and Fisheries Fund, but commissioned by Marine Scotland. So the people in Scotland who are the licensors, they're in charge of licensing and for all of the developments. And there are different resources, presentations, and outputs from workshops available at this link. But one thing that has come up time and time again within this cumulative effects framework project is this one of data quality, recording data in different ways. Because in this project, what we're trying to do is within Scottish waters, do a cumulative effects assessment for the whole of Scottish waters with all wind turbines, all wind farms on a large scale. So it's trying to pull together all the information for all the different developments. And when everything has been collected in a slightly different way, and some of these data are actually quite old, trying to get to understand what the data are, what it actually might mean, the survey methods that we use to collect the data even, those information sometimes just are not there. And so this is one thing that is, I think, really important, to make sure that data are collected consistently and that information about the methods are recorded. Now, another project that is literally just starting, it has just been funded by the Norwegian Research Council, and that again I'm involved in, is a project called Marine Spatial Planning and Cumulative Impacts of Blue Growth on Seabirds. And this is a project which is going to look at only Norwegian waters. But again, that's a large scale Norwegian waters. And look at not only renewable energy, but potentially shipping and oil and gas extraction and other activities that may impact seabirds. So not just renewable energy. And it's going to take a marine spatial planning approach, looking at the different activities that exist in Norwegian waters and how they might impact seabirds. So there's a large element of collating data again on seabird demography, on on reproduction and survival and how those might be affected by the different developments that will be included or the different activities that will be included in this project. But also it's going to take it a step further and try and include individual-based modeling to try and understand the sensitivity of those species to those different activities. So how is it that renewables impact Norwegian seabirds, and to use individual-based modeling to produce sensitivity scores that then feed into this larger spatial planning exercise. So this is at the very beginning. It's a project that will go on until 2025. So there may be opportunities to join workshops, for example, and learn together as we go along through this process, if anybody's interested. Okay, so this is me coming to the end now, but I thought I'd try and give a few key points, not so much how to do cumulative impact assessments, but what to think about. We all know that cumulative impact assessments can be complex. It's hard to think about cumulative impacts. They are hard things to think about. It's really important to know what is considered cumulative. It's important to use and produce clear definitions to avoid confusion. And I can't stress that enough. To produce clear guidelines and to ensure general agreement before doing the cumulative impact assessments. The methods will always come later. The appropriate method for the question or for the boundaries that have been set or the species that you're interested in, there are methods available, and I've shown or described some of those methods. But the results of any of those methods, the results of what you do, will only be as good as the agreements that are made in the first place. Everybody needs to agree on what it is that needs to be included in your impact assessment, your cumulative impact assessment, and what are you doing? Because if you don't have buy-in from everybody, then the results may be questioned. And then that's a lot of time wasted by everybody, and it affects the rate of developments. If things are uncertain and things are questioned, it can be a long time in the planning process. So making sure that these things, these definitions, these agreements, these guidelines, understanding what goes into an assessment is key from the very beginning. And then you can find the most appropriate method to answer the questions to ensure that the developments can go ahead, but can go ahead sustainably. They can go ahead without impacting the birds. And where a development shouldn't actually go ahead, people are able to make those decisions because the information is available to them. That's all from me, and thank you very much for listening. I hope that has been helpful.
はい、増田博士ありがとうございました。はいではですね、ここからは質問がいくつか来ておりますので、皆様からいただいて